Hello, ladies and gentlemen. Welcome back to day 2 or part 2 of chapter 7.2. All right, today we're going to be talking about adding and subtracting constants and looking at the rules of means, standard deviations, and variance. Some really important rules, details. Remember, folks, details, details, details. All right, here we go. So, what I have is a list of numbers here. So my first list, I have 2, 4, 6, 8, 10. All right. And I'm going to go ahead and find the mean and the standard deviation. And remember, the standard deviation squared is called the variance. All right. So I'm going to go ahead. I've already got these typed in just to save a little bit of time. So I type these in to the list number 1. So I'm going to go ahead and do the stat, calculate number 1. And I'm going to find, when I do that, it's going to give me the mean. So we can see right here the mean is 6. Okay, the standard deviation, ladies and gentlemen, we're going to use the sigma one. Okay, so we're going to say that we know the population standard deviation. So the standard deviation is 2.82. I'm going to go to the 8. All right, so I'm going to write those down. So the mean is 6. Let me switch colors here. The mean is 6. The standard deviation is 2.828. All right, and if I take the standard deviation and I square that, folks, okay, remember that's the variance. Take and square the standard deviation. I'm going to get, and I'm going to round this to 7.998. Okay, now the second column, I added 7 to those numbers. And again, I already typed these into my list, so they're in list number 2. So what is adding going to do to those 3 things? All right, so what I'm going to do is I'm going to go stat, calculate number 1. Now, since I have them in a different list, folks, I have to tell the calculator to use list 2. So that's real easy. Just go second, and then the number 2 button is list 2. Okay, so I switch my list to list 2. Okay, so now I'm going to go ahead and I see that the mean went to 13, and oh look, the standard deviation did not change. Oh, so the mean went to 13, and the standard deviation is still 2.828. That would mean the variance is also the same. So the variance didn't change. Okay, now that was adding 7. So, and it looks like the mean went up 7. Well, that makes sense. Okay. How about subtracting 5 from each x value? All right, well, I think you know what's going to happen here, right? So again, I've already typed those numbers into list 3. So I'm going to go ahead and I'm going to go to stat. I'm going to go to calculate. I'm going to pick number 1. I'm going to tell my calculator, okay, go to list 3, so second, number 3, and let's go take a look. Well, the mean is now 1, and the standard deviation did not change. Okay, so the mean is now 1, which is 5 less, right? The mean was 6, and I took away 5, so now the mean is 1. That makes sense. And the standard deviation did not change, which means the variance did not change. Okay, so what am I wanting you to gather from this information? All right, again, if I'm going too fast, remember you can pause and rewind. What I want you to gather from this information, folks, is that when you're adding or subtracting, the mean changes by that constant amount, but the variance and standard deviation do not. So adding and subtracting change the mean by whatever you added and subtracted by, but it does not change the standard deviation and the variance. Okay, now think about why. Okay, remember, so let's say my data goes from here to here. Okay, from here to here. When I add, my numbers are only, now remember, standard deviation measures how far away on average the numbers are from the mean. So by adding, all you're doing is shifting the numbers one way. The width, like the range, has not changed. By subtracting, it shifts it the other way, but again, the minimum and maximum and in the numbers, all they do is shift over. So that's why the standard deviation does not change, because remember, standard deviation, I'm going to say it one more time, is the average distance from the mean. And the average distance is not changing because the mean and all the numbers are changing one way or the other. All right, let's take a look at this next one. This one, we're multiplying by a constant. Okay, again, that first column is 2, 4, 6, 8, 10. And the second column, we're tripling all of the numbers. And then in the third column, we're multiplying by a half, so we're taking half of the numbers. Okay, well, the first one I can fill in because we already know, you know, this is 6, this is 2.828, and then this is 7.998. Now, I already typed these numbers into the calculator, so in my list 2, I have, whoops, nope, I got the, hold on here, let's see. I've got them in list 3, okay? I got them in list 3. 6, 12, 18, 24, 30, I have in my list number 3. So what I'm going to go ahead and do is I'm going to go ahead and do the, okay, go ahead and quit. There we go. I'm going to go stat, calculate, number 1. And again, I've got the tripling, multiplying by 3 in list number 3. Okay, so I'm going to go ahead and find out what this says. So my mean is now 18. Okay, it was 6, now it's 18. Okay, oh, look at my standard deviation. My standard deviation was 2.828, but now it's 8.48. We're going to round that to 9. Oh, okay, so the standard deviation changed. So the mean is now 18, and the standard deviation is 8.485. Okay, did I round that? Let me double check. Yeah, 8.485. Now, if I do the variance, folks, that means I have to square it, right? I have to square it. So if I square the standard deviation, I'm going to get 17, no, not 17. Writing my numbers backwards. 71.995. Okay, so they all changed. Okay, they all changed. And they all changed by a factor of 6, it looks like. So let me double check. So let me go ahead and do 2.828 and let me multiply that by 3. Do I get, I sure do, I get 8. Now it's, remember rounding here, we rounded it. So we get 8.484, but if you do the whole number, you get 8.485. Okay, remember we do have some rounding. That doesn't always match up depending upon when we rounded our problem. So yep, so the standard deviation also increased by a factor of 3. Okay, well, I bet you know what's going to happen here, right? Okay, the half. So I've got those numbers in list number 4. Okay, so I've got the 1, 2, 3, 4, 5. Whoops, I've got an extra number in there. So I need to get rid of that 0 before I do this, or my data will be completely wrong. There we go. All right, so now I'm going to go ahead and I'm going to do the stat, calculate number 1, but I'm going to do list 4. So second number 4 is list 4. And, yep, So the mean is now 3, which is half of what it was, and the standard deviation is 1.414, which is half of what it was. So let me go ahead and fill those in. So this is now 3. This is 1.414. And if I now take that and square it for the variance, 1.999. You're going, well, why do we need to worry about variance? Okay, something really important is going to occur, so please listen when we get to it. All right, so what do I want you to notice from this? This is something you need to keep in your mind. The mean and the variance and standard deviation all change when multiplying by a constant. Okay? Why? What's happening? Well, when you multiply, you either spread them out or squeeze them together. So when you multiply by a number bigger than 1, okay, it's going to spread it out. It's going to get bigger. Everything is. And then all of the numbers are going to be further away from the mean, right? They're going to be further. If the spreads out, they're further away from the mean. If you multiply by a number between 0 and 1, they're going to squeeze together. So they're not quite as spread out. So yes, your mean and standard deviation and variance are going to change. Okay, so keep that in mind. Know those rules by heart. All right, we got more to talk about though. All right, so in this problem, again, this is a discrete probability, so let's review what's going on here. So let's find the expected value. Remember, expected value is the mean. So this is from our last lesson. So we're going to go ahead and we're going to take 1 times its probability plus 2 times its probability plus 3 times its probability, plus 4 times its probability. Again, this is finding the expected value or the mean or the average. Now, in this situation, we end up, this is just a general problem. I didn't put any context into it, okay? We get an average of 3.1 or expected value, 3.1. Okay? Now, remember that. Now let's say that we're going to take, okay, so let me go back a second. So this is our x values, right? 1, 2, 3, 4, 5. Those are our x values. Now let's say we're going to take each of those x values and we're going to double it and add 1. We're going to double it and add 1. So now this would be a 3. Okay, now I'm going to take the 2 from the last problem. I'm going to double it and add 1, so that's going to be a 5. So this will be a 5. Okay, now I'm going to double the 3 and add 1, and that's going to be a 7. Double the 4 and add 1, that's going to be a 9. And we're going to take 5 and double it and add 1, and that's going to be 11. Okay, so this is my new random variable by doubling and adding 1 to each number of the x. Now that is the y distribution. Okay, so what happens here if I find the mean or the expected value? Well, if I went through and I did 3 times 0.1 plus 5 times 0.2 plus 7 times 0.3 plus 9 times 0.3 plus 11 times 0.1. Okay, if I did all of that work, folks, I'm going to get 7.2. But we don't need to do all of that work because in our last problem, the expected value of x, remember, was 3.1, right? So now if I want to know notice my notation here, folks. If I want to know what is the expected value of the y, all I need to do is take 2 times, not 2 times, silly Mr. Ellering. Yeah, it's 2. I'm right. 2 times the expected value of x and add 1 to it. So all I needed to do to find it, instead of doing all of that work, all I needed to do was take 2 times 3.1 and add 1 to it, and guess what? I got 7.2. Okay? This is why understanding those rules will help quite a bit. Now, a little bit more on notation, folks. A little bit more on notation. So let me get this correct, write this down. So the expected value of y equals, okay, this is the correct notation for this. We would write the expected value with 2x plus 1. So that's what that looks like, which means now I'm going to flip this around again. This really doesn't matter, but this is how they do it in the book, and this is how my professors did it when we were doing statistics. They put the constant first plus then 2 times the mean of x. So this is just your notation. So know how to read the notation for that. Okay, which leads us to what rule number 1 is saying. So what I'm doing is I'm following the format of the rule. So here's the rule. Oops, nope, that's not the rule. Let's see. Oh, I don't have the rule written down. Okay, hold on, let me get that written down. All right, I quickly wrote that rule down. So this is in your book. Go look. Chapter 7.2. Rule number 1. If x is a random variable and a and b are fixed numbers, then, again, look at the notation here. The mean a plus bx equals a plus b times whatever the mean was. Okay, so that's rule number 1. All right, let's keep going. So in this situation, let's say that we have, we're defining a new variable here. All right, so again, we're going to take 4 times 1 minus 5, which means now that this would be a -1, right? This would be -1. And 4 times 2 minus 5, that's going to give us 3, I believe. 8 minus 5 is 3. Okay. And then the next one would be, if we plug it in, folks, to save time here, I'm going to just do this. To plug it in, I believe we would get 7. Yep, and then 11, and then I believe 15. Let's see. Yep. So I'm not going to do all of this work to figure out what the expected value is, folks, because again, remember the expected value of x is 3.1. So all we're going to need to do here, and I'm going to use the correct notation this time, is I'm going to take -5 plus the mean, okay, or the expected value of the, hold on here. Okay, sorry, it's the 4 that comes next. My mind went blank there for a second. So I'm going to go 4 times the mean of what x was, right? So that means I'm going to take, so the new expected value, everyone. Now I'm going to say expected value, mean. I'm going to use those interchangeably. So -5 plus 4 times 3.1. And let's see, I don't actually have that written down, so let me figure that out. -5 plus 4 times 3.1, and I'm going to get 7.4. And that's the new mean. All right, moving on. Oh, here I've got it written. Okay, thought I had it written. This is what happens when you don't look ahead on your notes. So there's rule number 1, what I just wrote earlier. It's on page 494. Okay, moving on. Rule number 2. Rule number 2. Let's say X represents the math SAT score and Y represents the mean verbal SAT score. Okay, so you can see it right here. then what's the overall score? Okay, all this is saying, ladies and gentlemen, is that this is a super easy rule. All you do is add them together. That's it. So you're going to take the mean of x plus the mean or expected value of y and add them together. So 625 plus 590. Now this is rules for means. Okay, this is the rules for the means or the expected value. And so you're going to get, what is that, 1215. So that's your overall score. That's rule number 2 for means. All right. So you'll see that on page 494 also. Again, this is the rules for means. Okay, so look at the notation, folks. Look at how the notation is. You need to know your notation. I'm teaching you how to read statistics. Okay, now, rules for variances. Folks, you cannot work directly with standard deviations. Let me repeat that. I'm going to repeat that 2 more times. You cannot work directly with standard deviations. In fact, I'm going to type that. Okay? You cannot work directly with standard deviations. You have to work with variances. Okay, you cannot work directly with standard deviations. You have to work with variances. So that means if you're given a standard deviation, you are going to have to convert it into a variance. If you're given a standard deviation, you're going to have to convert it to a variance, then you can work with it. All right, so let's review, okay, if you recall, to find the variance. All right, again, this is using that original problem. So if you remember, the mean again is 3.1, or the expected value, right? Okay, so to find the variance, remember we go 1 minus the mean squared times its probability plus the value minus the next value minus the mean squared times its probability plus. Okay, I'm going to pause this to save time, and then when you come back, it'll be done. Oh, my thing disappeared. Never mind, I'm going to keep writing it. I don't know where my pause button went. All right, so the next one would be 3 minus 3.1 squared times 0.3 plus 4 minus 3.1 squared times the 0.3 plus, again, there's no shortcuts to this, everyone. So type carefully on your calculator. All right, and we end up with 1.29. Now that's the variance. That's the variance. All right, now, remember, adding or subtracting the variance and standard deviation do not change. Adding and subtracting the variance and standard deviation do not change. Multiplying by a constant, the variance and standard deviation change. Remember that. Okay, so now let's go back to here. Okay, now, here's our new random variable, 2x plus 1. So we multiplied the x values by 2 and added 1, right? Okay, now if I wanted to find the variance, okay, I would now go 3 minus, and if you remember, the expected value for that is, let me double check to make sure I don't goof, is 7.2. Okay, so I'd go 3 minus 7.2 squared times 0.1. Now, there's a shortcut to this now because we already know some information, but you could go through all of this process again. Okay, I'm just now going to go dot, dot, dot. Okay, you could keep going. And we would come up with an answer of 5.16. Okay, if you don't believe me, try it. But what did we learn earlier? Okay, let me write this out. So here's the variance, standard deviation squared. And let me do the notation here. So I am taking the variance 2x plus 1. Okay, that's that new rule right there, right? Well, remember, adding does not change the variance. So this plus 1 means nothing. So what we end up doing, folks, is this. The 2 in front, so variance is the standard deviation squared, right? Variance is the standard deviation squared. So the 2, the constant in front of that x, you have to take it and square it because, again, the variance is the standard deviation squared. So take the 2, square it, and then you're going to multiply it to the variance of x. Ooh, the variance of x, if you remember, let me go back and make sure I get this right, is 7.998 when we rounded it. Okay, well, if you remember, the standard deviation of x, make sure I got the right one here. Hold on here, folks. Oh, wait, hold on. I'm goofy. Hold on here. Ladies and gentlemen, sorry, I was going too far back. I was going back to the first thing we did. Hold on here. So the variance of the original, okay, let me back up. Okay, here it is, right? So this is the variance of the original one, 1.29. Okay, sorry about that. I was going back to that first problem. So the variance of x is 1.29. So the variance of x is 1. Okay, hold on. Now I need my pen. There we go, 1.29. And the standard deviation of that would be the square root of that, okay, which we didn't find, but we don't need to do that at the moment. So what we're going to do here, ladies and gentlemen, is we're going to go ahead and take 2 squared, which is 4, times the variance, again, which is 1.29. So the variance, if we do that, 4 times 1.29, well, guess what, everybody? We're going to get 5.16. Remember, adding or subtracting does not affect the variance, so this plus 1 meant nothing. But when you do the notation, you do need to leave it there like that. All right, let's keep rolling. Okay, so in this situation, okay, 4 times x minus 5. So let me write this out. So that would equal the variance of 4x minus 5. But now remember, the minus 5 has no effect on the variance. So I will write that as 4 squared, because you got to square it, because the variance is the standard deviation squared. 4 squared times the variance. So that means it's 4 squared times the 1.29. And that would be 16 times the 1.29. All right, do I have that? Yes, I do. So that's going to give us 20.64. So if I went one step further and I did the standard deviation of m, that would be the square root of the variance of m, which would be the square root of 20.64. And that's going to be approximately 4.54. Okay, so let's look at the general rule here, ladies and gentlemen. Rule number 1, rules for variances, page 494. Okay, again, look at it right here. Again, adding or subtracting something, notice that disappeared when I rewrote it, b squared times the variance. And note it's on independent random variables, okay? Rule number 2, okay, this one's weird. I want to point this out to you folks, okay? First of all, the sum. Okay, well, that's pretty straightforward, right? You have two variances, you simply add them together. Okay, again, you cannot do that with standard deviations. Remember, you can never work directly with standard deviations. You got to work with variances. But what I want to point out here, folks, is this, and I'm going to rewrite this down here. The variance of x minus y equals, now this is not a typo, it's the variance of x plus the variance of y. Even though this has a minus in there, we're still going to add them together. And you're going, why? What in the world? Remember, folks, if you square a negative or the minus, it becomes a positive. Okay, think about it. Minus, if I change this to x plus negative y, right? That's the same as x minus y. When I square it, it becomes positive. So that's why there's a plus there. So you never subtract variances. You can only add your variances. All right, let's see this in practice. Okay, which I already went over them on that last page. Whoops, nope, I guess I want to do an example here. So let's see. Okay, so hold on here, I'm going to pause. All right, so let's keep going here. Right before you find the variance, this is what I just got done pointing out. Right before you find the variance of a data set, you are squaring the differences, and when we square -1, it becomes +1. This is why we always add variances. You can add variances together, but not standard deviations. Remember, you can never work directly with standard deviations. Never work directly with standard deviation. Work with the variance and then find the standard deviation. I cannot emphasize that enough. Okay, let's look at an example. So let's say it cost $1 for the Tri-State Pick 3. The prize is $500. So remember how this works to find the mean. If we take 500, you have 1 in 1,000 chance of winning. Okay, you have 1 in 1,000 chance of winning. So there's 1,000 different 3-digit numbers, right? 1,000 3-digit numbers. So you have 1 chance out of 1,000 of winning. And this part's not necessary, but you will win $0. You have 999 out of 1,000. So if we figure that out, ladies and gentlemen, that's 50 cents. Okay? So the average payout is 50 cents, and on average, people will win 50 cents, okay, in the long run. In the long run, the state's going to keep 50 cents of every dollar spent on this game. So the variance, ladies and gentlemen, is going to be 500 minus the 0.5 squared times 1 out of 1,000. Plus, now again, this part's not necessary, but I'm going to show it anyway. Well, no, this is necessary. You can't skip this. You do need to do this part. 0 minus the 50 cents squared times the 999 out of 1,000. So the variance, ladies and gentlemen, is 249.75. So type that in. You should get 249.75. So the standard deviation is the square root of that. So we get the standard deviation is $15.80. Okay, so again, to find the mean, the expected value, and then find the variance, and then we can find the standard deviation. So if you bought a ticket on Tuesday, folks, so this was buying a ticket on Monday. Okay, this is buying a ticket on Monday, right? You bought a ticket on Monday. Then you bought a ticket on Tuesday. So now that's why. Are things going to change? No. Okay. The expected payout is still going to be 50 cents. The variance is still going to be 240, I'm putting a dollar sign on it, you don't have to, 75, and the standard deviation is going to be $15.80. So it's the same on Tuesday as it was on Wednesday, right? Yes. Okay, but now, what is the sum of them? The sum of the means? Well, Monday, I'll put Monday here and I'll put Tuesday here. Monday, the expected payout was 50 cents. Plus, well, Tuesday, it's the same. It's 50 cents. So over the 2 days, you buying a ticket, your expected amount is $1. You expect to win $1. I know you're either going to win 500 or 0, but that is the expected amount to pay out. And if you think about it, that's the expected amount the state's going to keep because they keep 50 cents of every dollar. Now, notice the variance, folks. We take Monday's variance and add it to Tuesday's variance, and we get, let's see, whoops, hold on here. Hold on, I'm goofy. The variance, Mr. Ellering, the variance. The variance is 249.75. So we take the variance of Monday plus the variance of Tuesday, and so add them together, the variance is 499.50. Okay, now to do the standard deviation, now we take the square root of 499.50, and we're going to find out that the standard deviation is $22.35. Okay, so on the calculator, let me show you this. So again, I take the sum of the variances and take the square root. So the sum of the variances is 499.50. So $22.35. Now, if you remember the standard deviation of the single day, the standard deviation of the single day, Monday or Tuesday, is 1580. And you'll notice if I add 1580 plus 1580, that definitely is not the $22.35. Okay, that is not correct. This is a very, very common mistake unless you get that rule down. I'm going to say it again. You cannot work directly with standard deviations. You have to work with the variance and then find the standard deviation. Okay, last one. So Tom and Greg play golf. Okay, Tom's average score is 110. Greg's average score is 100 strokes. Standard deviation 10, standard deviation 8. Find the difference. Find the difference between their scores. So 110 minus 100. The difference is 10 strokes, folks. The difference is 10 strokes. You can subtract the means. Now remember, find the difference between the standard deviations. Okay, so we have to take the variance and add it to the variance of the other person. So that means, ladies and gentlemen, you have to take 10 squared plus 8 squared. 10 squared plus 8 squared. That's going to give us 100, make sure I'm doing my math right here, 164. Yes. Yeah, 164. Okay, here we go. We're going to wrap this up, folks, because I think we have gone long enough. So now, to find the difference, I take the square root. And remember, we cannot subtract. We have to add. Now we're going to take the square root of that. That's going to give us the standard deviation, the sum of the standard deviations. Notice my notation. So we end up with, do I have that written down? I do, 12.8. So the difference between the standard deviation of this golf game is 12.8. Okay, I apologize if I got a little jumbled in there a little bit, folks, but rewind, rewatch if you need to. I think 42 minutes and 18 seconds is long enough. All right, folks, this is it for Chapter 7. We'll see you